Let us discuss types of functions today. There are two main type of function, 1-1 and onto. 1-1 also known as injective, onto also known as surjective, and if the function is both 1-1 and onto, it is called bijective. So, if I have to show that the function is bijective, I have to show that the function is 1-1 as well as the function is onto. Now, let us just go through the definition of injective function first, and then we will understand the surjective function then. A function f from x to y is defined to be 1-1 or injective if images of distinct element of x under f are distinct, that is for every x1 x2 belongs to x, fx1 is equal to fx2 implies x1 is equal to x2. If the image is same, then the element also should be same. If the images are same under f, fx1 is the image of x1 under f, fx2 is the image of x2 under f. So, if the images are same, the elements also should be same. Otherwise, f is called many-one function. If they are not same, then we call, if the function is not 1-1, we call it as many-one function. If the function is not 1-1, we call it as many-one function. Let us understand with the help of the diagram which what is 1-1 function and what is not 1-1 function, which is not 1-1. 1, 2, 3, D, B, C, A. 1 is having, 2 is having image B and 3 is having image C under F. So, here f of 1 is equal to D, f of 2 is equal to B and f of 3 is equal to C. So, different elements are having different images, right? But here, so it is a 1-1 function because each element has unique image. Every element is having one and only one image. But this is not 1-1 function. Why it is not 1-1 function? Because 1 is having two images here. F of 1 is equal to D and f of 1 is equal to B also. We can see that f of 1 is equal to f of 1. We should have this also equal, then only I will say that the function is 1-1. But this can happen in 1-1 function. This is valid in 1-1 function because these are different. They can have same image, right? Because we should have unique image. This element 2 is having only unique image which is C. Element 3 is having only one image which is C. Unique means only one image. But here element 1 is having two images. F of 1 is D, F of 1 is B. So, this is not 1-1 function for this. So, this less than type sign is not valid for 1-1 function, but this is valid. If this is the case only, then it is a 1-1 function. But here, why this is not a 1-1 function? Because here this type is also there, like this, less than type is also there. So, it is not 1-1 function. In simple language, we can just learn that if less than type is there, it is not 1-1. If like more than type is there, then it is 1-1 function. Now, let us just look at few examples how to prove the function is 1-1 and how to prove the function is not 1-1, how to show the function is not 1-1. So, I have taken the example first, f from R to R, fx is x plus 4. Okay, and we have one more definition for this. Means in simple word we can say that every element in domain has unique image in codomain, that we have already discussed. Every element in domain has unique image in codomain. So, let us now do this example, fx is equal to x plus 4. How to solve that the function is 1-1? What we will do? We will let fx1 is equal to fx2 where x1 comma x2 belongs to R, this R domain, right? And what I have to show? I have to show that x1 is equal to x2. I need to show x1 is equal to x2. Now, what is fx1? fx1 will be x1 plus 4 because fx is x plus 4. What is fx2? x2 plus 4. Now, 4 and 4 can be cancelled and what I will get? x1 is equal to x2. So, this only I need to show to prove that f is 1-1. So, we will write, so f is 1-1 because we started from fx1 is equal to fx2 and we landed on x1 is equal to x2. So, that is why f is 1-1. Now, another example, here also I will consider fx1 is equal to fx2 and what I have to show? I have to show that x1 is equal to x2. So, let us see whether it is a 1-1 function or not. x1 square is equal to x2 square because fx is x square in this case. So, we will have x1 square minus x2 square is equal to 0, x1 minus x2 and x1 plus x2 is equal to 0. So, I will get x1 is equal to x2, but I will also get x1 is equal to minus x2, right? x1 is equal to minus x2. So in this case it is not equal to x2. So this is not a 1 1 function, and for that I need to give one example also. Like I have f of 1 is 1 square, which is 1. F of minus 1 is minus 1 square, which is 1. Now I can see that these two values are equal, that is f of 1 is equal to f of minus 1, right? But 1 is not equal to minus 1, right? 1 also should be, these elements should be equal. Like here we have done fx1 is equal to fx2 implies x1 is equal to x2. Here fx1 is equal to fx2, but x1 is not equal to x2. It is 1 and it is minus 1. 1 is not equal to minus 1. So this is not a 1 1 function. F is not 1 1, and if it is not 1 1, we call it as many 1 function. If a function is not 1 1 function, we call it as many 1 function. So in each and every question, whenever we have to prove that a function is 1 1, we are going to do this only. We will consider fx1 is equal to fx2, then we will substitute the value, and if I am getting x1 is equal to x2, then it means function is 1 1, otherwise not. Now let us look into this onto function, surjective function. A function f from x to y is defined to be onto or surjective if every element of y is the image of some element of x under f. That is, for every y belongs to y, there exists an element x in x such that fx is equal to y. So in simple terms, with the help of the diagram, we will understand what is onto function. Every element in this codomain, for every y belongs to y, there exists an element x such that fx is equal to y. So for all these elements, we should have an element in x so that it is related. Like here, if they are related like this, this is not an onto function because 4 is not having any pre-image. We call it as from here to here it is image, from here to here it is pre-image. So 4 is not connected with any of this element, so this is not onto function. But this is onto function because here all the elements are connected with the elements in x. So if the function is, if any element is not related with this, then we call it as not onto function. Now how to prove the function is onto? How to prove the function is onto? We will consider, let y belongs to R be an arbitrary element such that we will consider fx is equal to y. And what we need to show here, we will show there exists an element x belongs to x for every, x belongs to R for every y belongs to R, because here I have taken the domain and codomain as R and R. So fx is equal to y, it means x plus 4 is equal to y. So it means x is equal to y minus 4. You can see that for every y belongs to R, x will also belongs to R. Here R stands for real number. If I will substitute any value of y in any real value in place of y, then whatever the number I will be getting, that number also will be belonging to R. So x belongs to R for every y belongs to R. So the function is onto. So f is onto here. F is an onto function. Now another example is f from R to R, where fx is equal to x square. So here also I will consider let y belongs to R be an arbitrary element, and I will be showing the same thing I should write. Y belongs to R be an arbitrary element such that fx is equal to y. Now here what is fx? Here fx is x square. Now x square is equal to y, it means x is equal to under root y plus minus under root y. But here this is not belongs to R if y is minus 1, because if y is minus 1, it will be under root minus 1, which is a complex number or imaginary number, that is iota. So here, so f is not onto. So we need to give example for this like this, because x is equal to plus minus under root y, it doesn't belong to R if y is equal to minus 1. It should belongs to R for every y belongs to R. But here I have got the example for which y belongs to R, but x doesn't belong to R. So, f is not onto.